when you're dealing with real electrification. Why? Because usually, if we look at power converters, inverters, any type of renewable energy dedicated systems, you have, I've put a few of the ones that you find in commercial applications and a bigger turbine. These solutions, they are tier specific. They're going to provide you, and they're going to, with a solution that's going to fit a certain amount of power, a certain amount of energy, a certain voltage level. But the problem is that some of these solutions, they are incompatible among themselves. I'm just putting an example here of different physical structures of batteries or different type of connectors. But it goes beyond that. And they do generate industrial dependence. I just put a few graphs here. The one on the bottom left, I think it's an interesting one to meditate about. The actually red curve that is there is obviously China, and that shows you how many photovoltaic cells actually come out of the Chinese production. And you can be very enthusiastic about photovoltaic power. In 25 years, you have to replace all your PV panels, and if they're all produced in China, that also creates technological dependency just as much as importing coal from another country or oil from the Middle East. Timelines are different, but in the end, it comes to the same. But I didn't limit myself to that. If you look at the chart on the upper left, the green that you see is the market share of the top five inverter producers in the world. And you see that they produce about 60% of all the inverters, and which means that a lot of them are coming from across the globe, maybe from manufacturing in China or in Europe, but they come to here, and you get the chart on the right shows Siemens as being the group who has almost 80% of the wind turbines been installed in 2017. That means that when we're talking about renewable energies, we're not talking about anything different from before. Because if maintenance becomes replacement, here I have a few pictures, a little bit hard to see, a few pictures of an inverter we opened up in NIWE, and the inverter blew up, and we opened up to take a look at what it is, and we saw there were some issues in the inverter, but in the end, the ultimate diagnosis that we could do is ship it actually in the factory. So you're just replacing. Then local practitioners become retailers. You're no longer developing. You're no longer doing something with technology. You're just selling somebody else's work for a profit. And finally, all we managed to do is to make technology to become an obstacle. Solar, thermal, solar heating systems, that's amazing, but each one have their own. If you want to interconnect them, if you want to make them more efficient, they're not made to. So they're an obstacle to the expansion of the system. They may be interesting in the beginning, but they will not be interesting in the long term. So the question is, how can we trigger expansion with technological independence while generating affordable electricity? And I want to ponder on that question. That's not an easy question. We're talking about being technological independent. That doesn't mean we are the only ones who know the technology, but that means that we know the technology to make it move. That's usually an expensive deal, which does not go with affordability. But we have a solution. We have an answer. Doesn't mean it's the answer, but it's an answer. We believe that an open source, modular, and multifunction power electronics converter is the answer to provide bottom-up, multi-tier, rural microgrid deployment and expansion. Now that's a long phrase. It can be quite boring to read. So let's break this down. Let's go deeper into the analysis. Let's start with open source and bottom-up. How do they relate with each other? Open source is a way to share knowledge. When you share knowledge through open source licenses, that means that everybody has access to it. Nobody can lock it down. That means that everybody can work on it, everybody can benefit from it, study it, contribute to it, but nobody can claim royalties from it. Nobody can say, oh, this is my idea, I want to get paid because you're using it. No, that doesn't work like that. Everybody has access, everybody collaborates. But what does it have to do with rural electrification? Well, basically, if you have access to the technology, if you can study its plans, if you can read its design sheet into the detail, if you have access to the details, you can diversify your business model. You're no longer a retailer. You can install the technology, you can maintain the technology, you can help develop it, you can educate with the technology, you can even operate the technology. That means that you're no longer waiting for somebody to develop a solution for you. You make your own. And if in your community, pay-as-you-go is not culturally feasible, but rather some other type of tarification, you can implement it because you have a hand on the technology. And that's a very basic thing. It goes way before we talk about what is the technical solution. It's what's the social solution for your problem. So open source is a prerequisite for us to be technologically independent because we are hiding in plain sight. If you need to know, you know. And if you need to expand, if you need to change, if you need to maintain it,